Hi, dear learners, Pranam. You are all welcome here on your channel Celebrating Studies. Get ready for an exciting journey into Chapter 3 Linear Equations in Two Variables for Class 10th boards to be evaluated in 2027 under the CBSE pattern. And I am Arun Hira, your companion in our marvelous journey. This is going to be an amazing journey to be enjoyed to the highest level. Here, all concepts shall be dealt with in depth, detail, and with comprehensive intellectual understanding. Here, we can see some explorers who are highly enthusiastic and are well prepared for their exciting journey and are equipped with all required tools. Likewise, we shall also be supplied with all the tools of our journey into island linear equations in two variables in the form of formula and conceptual framework. Linear equations in two variables is a very vibrant topic to be mastered. It has two variables that are commanding the entire chapter. These two variables can explain the outcomes of linear graphs as well as explain the day-to-day situations with a tinge of sharp clarity. So let's begin this charming journey with a tagline target not less than 100%. Here is a linear equation which is represented in front of you. Ax plus by is equal to c, where a is the coefficient of x, b is the coefficient of y, and c is a constant. So firstly, we will see there are two variables x and y. Why these are called variables? Because their values can be changed, can be altered. But the values of a, b, and c can never be changed because it is already given in the question in the form of real numbers. One more representation of linear equation can be a1x plus b1y plus c1 is equal to 0, as well as a2x plus b2y plus c2 is equal to 0. Why there are given a set of two equations? Because there are two variables x and y. So in order to get their values, we always have to solve two equations. That is why two linear equations are provided in each and every question in this chapter. Here plus a1 is the coefficient of x in linear equation 1, plus b1 is the coefficient of y in linear equation 1, plus c1 is the constant term in linear equation 1, plus a2 is the coefficient of y in linear equation second, plus b2 is the coefficient of y in linear equation second, plus c2 is the constant term in linear equation second. Now, whenever we are going to make or draw the graph which is based on the values of these two linear equations, we will always get a straight line. Why? Because see, here the highest power of x or the degree of x is 1. Here also the degree of y is 1. Here the degree of x is 1. Here the degree of y is 1. Suppose the degree of x would be 2, or suppose the power of x would be 2, then this equation would be called as quadratic equation rather than linear equation. If suppose the value of the power of x would be 3, then this would be called as cubic equation rather than linear equation. Suppose if the value of power of x or the degree of x would be 4, then it would be called as biquadratic equation rather than linear equation. But here, as we can see, the degree or the power of x and y in both of these two equations is 1, hence it is called linear equation, and hence the graph which is based on these two equations would always be a straight line. Now the straight lines can be having three situations. In one situation they can intersecting, in other situation they can be parallel, in third situation they can be coincident, means overlapping. Now if they are intersecting at one point, then we are going to get one solution. If they are going to not intersecting at all, means if they are parallel lines, then we are getting no solution. If they are overlapping or if they are coincident lines, then we are getting infinite solutions. In other way also we can see, if a1 upon a2 is not equal to b1 upon b2, then we are getting one solution or unique solution or exactly one solution, and the system would be independent or consistent. If a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, then the system would give us no solution, or we can say that the system is inconsistent in nature. If it would be a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then the system would give us infinite solutions and the lines are coincident or overlapping. or we can say the system is dependent. Now, at one more time, we are going to see this. If there would be unique solution, then it would be A1 upon A2 is not equal to B1 upon B2 and the system is consistent. If it is having an infinite number of solutions, then it would be A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2 and the system is consistent. If there would be no solution, then we can see the values would be such that A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2 and the system is inconsistent. Now, four things we will see in this, four things here means there are basically 12 phrases which we have to learn or which we have to understand with a full detail. Number one is that here it is a set of four words. What is the first word? Unique solution, intersecting lines, consistent, independent. These four words are coming under this diagram. Now, what are the other set of four words which is here only? Coincident lines, consistent solution, consistent system, dependent system, as well as infinitely many solution. Here, no solutions, parallel lines, inconsistent and independent. If we are going to get mastery of the set of these four words here, four words here, four words here, in total there would be 12 words. Then it would be highly easy for us to understand each and every questions without any mistake. Now we can see one more time, we are going to make a quick recap. If A1 upon A2 is not equal to B1 upon B2, then the lines are intersecting and they are having as exactly one solution or unique solution. If it is A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, then the lines are coincident and they are having infinitely many solutions and we can say the lines are overlapping. If A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2, then the lines would be parallel lines and we are getting no solutions because they are meeting at no place. No any common point would be there of their intersection. Now, more we will see graphical representation, then our clarity would be at peak. Just see, this is the line 3x plus 2y minus 12 is equal to 0 and on this line one point lies 0 comma 6. Now we are going to put 0 comma 6 in this. First of all, I am telling you what is this, that you know very well. It is quadrant first, it is quadrant 2, it is quadrant 3, it is quadrant 4. It is positive x-axis, it is minus negative x-axis, it is positive y-axis, it is negative y-axis. Here we can see first point or you can say first value is called epsica and this is called ordinate and combinedly we can call it as coordinate that we have studied in our 9 classes. Okay, now just see this D point states that the distance of point D from x-axis is 0 and its distance from y-axis would be 6 units. So this is the point 1, 2, 3, 4, 5, 6. So this is the solution of this line. How I'm going to prove it to you? Instead of x, just put 0. Instead of y, put 6. Now just see 3 into 0 is 0. 2 into 6 is 12. So 0 plus 12 is 12. 12 minus 12 is 0. So 0 is equal to 0. Hence, this point is going to satisfy this equation. We can take this also p 2 comma 3. Now instead of x, put 2. Instead of y, put 3. Now just see 3 into 2 is 6 plus 2 into 3 is 6. 6 plus 6 is 12, 12 minus 12 is 0 and 0 is equal to 0. So this point and this point, both of these points are going to satisfy this equation. So these two are the solution of this equation. Likewise, we can put 4 comma 0 and we are getting the same answer 0 equal to 0. How? Just see, instead of x, put 4. 3 into 4 is 12. 12 plus 2 into 0 because y is 0 here. 2 into 0 is 0. So 12 plus 0 is 12 and 12 minus 12 is 0. 0 is equal to 0 and this point is also going to satisfy this equation. Likewise, we can see this here. Here it is minus 1 comma 0. Minus 1 is the distance of point A on the negative side of x-axis up to unit 1. So it is minus 1. But here just see the ordinate point, it is 0. So this point is lying on x-axis. This point and now just see this point, it is having 2 unit distance from x-axis and 3 unit distance from y-axis. So 1, 2 here and it is 1, 2, 3 here. So it is a rectangle. And just see, it is having 5 unit distance from x-axis and 6 unit distance from y-axis. So this. Now these 3 points, -1, 0, 2, 3 and 5, 6. It is going to satisfy this equation, which is x minus y plus 1 is equal to 0. How? That I am going to show it to you. Instead of x, just put -1. So -1 minus 0, because y is 0, -1 -1 and -0 will give you -1. -1 plus 1 will give you 0. 0 is equal to 0. So this point, which is capital A, is going to satisfy this equation. Now, if I'm going to put the point P in this, then also I am getting the same answer. 0 is equal to 0. How? Just see. Instead of x, I am going to put 2. Instead of y, I am going to put 3. So 2 minus 3 will give us -1. -1 plus 1 is 0. 0 is equal to 0. So this point is also going to satisfy this equation. Now third, I am taking B, that is 5, 6. So 5 minus 6 is -1. -1 plus 1 is equal to 0. So 0 is equal to 0. So capital B, which is 5, 6, is also going to satisfy this equation. Now the most important, or you can say most vibrant thing, is that this point P is common to both of these two lines. So it is the point of intersection, and hence it is called the solution of these two equations. It means when we are going to put point P 2, 3 in both of these two equations, we are getting 0 equal to 0. 0 equal to 0 means it is going to satisfy this, as well as it is going to satisfy this equation. So this is the graphical representation. Now the same thing we can see it here. How we are getting these points, that is what I'm going to tell you, because this is going to be applied in our further word problems also, which are going to do in our next video. X plus y is equal to 4. This is the linear equation in two variables, which is given in the question. Now instead of x, we can take any value. For example, if we are going to take 0, what we are getting, 0 plus y is equal to 4, means y is equal to 4. See, now instead of x, if we are going to put 4, so 4 plus y is equal to 4, which means y is equal to 4 minus 4, which is giving us 0. Now if x is 2, so 2 plus y is equal to 4, so y is equal to 4 minus 2, that is 2. So both are getting 2 and 2. Now we are going to plot these points 0, 4, 4, 0 and 2, 2, which is going to represent x plus y is equal to 4 equation. Now we can see this. First point is 0, 4. So where is the 0, 4? 0, 4 is there because it is lying on the y-axis, because its epsilon is 0. So this is 0, 4. Now if we see here, it is 4, 0. Now where is 4, 0? 4, 0 is there only. And in between it is 2, 2. It is having 2 unit distance from both the axes, 1, 2 here, and it is 1, 2 here, like this. Now we see next, 2x plus 3y is equal to 6. Now instead of x, we are going to put 3. So 3 to the 6 plus 3y is equal to 6. So 3y is equal to 6 minus 6, that is 0. So first point is 3, 0. Now we can see this. It is 3, 0. So it is 1, 2, 3. 3, 0 is this point. Now next is 0, 2. How we are getting it? Now I am telling you, instead of x, if I am going to put 0, 2 into 0 is 0. 0 plus 3y is 3y. So 3y is equal to 6. So y is equal to 6 upon 3, that is 2. Now instead of x, I am going to put -3. So 2 into -3 is -6. -6 plus 3y is equal to 6. So 3y is equal to 6 plus 6. So 6 plus 6 is 12. So 3y is equal to 12. Means y is equal to 12 upon 3, that is 4. Now I'm going to plot these 3 points, 3, 0, 0, 2 and -3, 4 to represent this equation. 2x plus 3y is equal to 6. Now see here, one point is this -3, 4. This is this point. Now why it is this? Because see, it is 3 unit from the x-axis, 1, 2, 3, -3, and 4 unit from here, 1, 2, 3, 4. Now next is 0, 2. Now it is 0, 2, it is 1, 2. So, and from y-axis, it is having 2 units distance. Now next is 3, 0. Now 1, 2, 3, and on y-axis, it has no distance because it is given 0 as coordinate. So this point lies on x-axis. Now I'm going to join 3, 0, 0, 2 and -3, 4, and I'm getting this line. So this is the point of intersection. If I see very minutely what we are getting, it is having the distance of 6 unit, 1, 2, 3, 4, 5, 6 unit from x-axis and -2 unit from y-axis, 1, 2. So this is the point of intersection, 6, -2. Hence the solution is 6 comma minus 2, which is going to satisfy both of these two equations. I hope you get this. Okay, one more thing I am showing it to you. Why I am taking this data? Because here we are getting something in denominator which is 2. This is the problem. Now, can we write 2x plus 3y is equal to 11 as 2x is equal to 11 minus 3y? So, x is equal to 11 minus 3y upon 2. Now, take the value of y such that it is going to be divided by 2 in a proper way. Proper way means we are getting the decimal. If we are getting the decimal, it should be in 0.5 because it is very easy to plot 0.5 in the graph, or we should try our best to get no decimal at all. How I am going to show you. Instead of y, if we are going to put 0, then what I am getting 11 minus 3 into 0, that is 0. So 11 minus 0 is 11. So 11 by 2 is 5.5. 5.5 is simplistically depicted on the graph. Now we are going to take y as 1. Now 3 into 1 is 1. 11 minus 3 is 8. 8 upon 2 is 4. It is a natural number. Now I'm going to take y as 3. 3 3 is 9. 11 minus 9 is 2. 2 by 2 is 1. Again 1 is a natural number. It is very simple to represent these on the graph. Now here it is so very simple already. 1x plus 2y is equal to 7. X can be written as 7 minus 2y. Now I can take y as 0. So 7 minus 0 is 7. Now I am taking y as 2. So 2 to the 4, 7 minus 4 is 3. Now y as 3. 3 to the 6, 7 minus 6 is 1. Now I'm going to plot this as we were doing in the previous. Here the point of intersection is 1 comma 3. See, this is the peculiar thing I am going to show it to you. Here I am getting 1 comma 3 and here also I am getting 1 comma 3. But sometime it is given, sometime it is not given. For example, here I am seeing not even a single point which is going to matter. Doesn't matter. So I am getting 6 comma minus 2 is the point of intersection. Here the point of intersection is 1 comma 3, 1 comma 3. It can be represented through this table. It may not be represented through this table. That doesn't matter. So this is the graph. So all the concepts are totally mentioned here. So now we are highly ready to get start our journey in a full-fledged mode in the next video.